Hi, welcome to HackMakeMod. I'm David, and this is a belt sander. And today we're gonna turn this into an RC car. I remember as a kid seeing a belt sander like this and thinking, it looks like a really cool vehicle. I thought now that I saw it in the store again, I now have the skill and resources to make one of these drivable. So I got a hold of Chad's credit card and I bought one. This is an 18-volt cordless belt sander. I'm gonna turn this one into an tracked RC car. Aside from making it drivable, I also want to make sure I don't permanently change anything about the belt sander because I want to use it for like sanding stuff. To do that, I'm going to steal the front end of a very old beaten up RC car that I had hanging on the wall. I want to use the front end of this car to drastically cut down on design time. There are some small things that we need to address. The first one being the steering, and the original steering servo is mounted all the way back here and has two linkage arms, which steers both wheels with one servo. The problem is that this takes a lot of space. I think I have a solution for this issue, but first let me get it deconstructed so I can show you what I'm thinking. Okay, so this is where I'm currently at. I cut this plate off. So this is the front end of the RC car, so it has the steering. I want this to be as compact as possible. I also want it to be removable very easily. I don't want to modify the belt sander in any way if I can. Like, it would be really cool if it was just an add-on. So I needed to solve the front steering problem. So what I'm going to do is use these servos. These are from Tricopters, and these are stainless steel with feedback wire. They're super strong, very compact, and luckily it's small enough to fit inside of the arm here, this cutout. I'm just going to 3D print a little mount that makes it pop up a little bit, and it makes the geometry of the steering a lot better. So now everything is nice and compact inside of this frame here. So it's going to be two servos, one for each wheel, and I'm going to mix that in the radio. The next issue we have to figure out is how we're going to mount the RC car wheels to the belt sander. I'm going to mount this to the battery like that. It's going to be pretty cool. You can just shove this in here like that, and it's going to stay on there. I'm going to 3D print some stuff. Hold on. Okay, so the first part we're going to design is a holder for this battery, so it's easy to take off and change the battery and charge the battery if we need to. So this is what I came up with. Very basic one that just slides on here. To make this a snap fit, I made it 0.2 millimeters shorter than the real item. So hopefully it's just gonna like slide on and be really tight without being too tight. So to make this car look a little cooler and also last a little bit longer, I made this little bumper. It mounts in the front end of the RC car and it goes up over the suspension and mounts to the top of the battery holder. This is to make the whole structure a bit more rigid, and it makes it look really cool. And I thought, when I have this front end thingy on the RC car, why not add a light bar? It's very straightforward. It's just 4 cups that I put at an angle, and I made a little mount on the back. This is just gonna mount straight to that bumper. Very basic, since I'm not gonna go and bash around this car. It doesn't need to be super durable. It just has to look super cool. Now that we have a way to mount the RC wheels to the belt sander, and it's starting to look pretty cool, we have to figure out a way to send power to the servos controlling the wheels, and a way to trigger the belt sander's throttle. Thought the best way to take care of both of these issues is by 3D printing an electronics box attachment. So this is somewhere we can mount the electronics, like the receiver and the receiver battery that we use to power the servos with. So this is how it came out in real life. So what I did was I designed it after this dust collection bag that goes on the belt grinder here normally. So you have that there, and it sucks up dust and collects it here. So I thought, since we're not going to use this, we can mount something on this section here. So I made this part to be the length in between here. So it's like wedges itself in here and sits very snugly. And why I made it so tight is because I mounted the servo for the throttle on the back side of it. So it needs good fit against these parts here. Otherwise, this would just flex when it's trying to push on the throttle. I made plenty of space in here to be able to fit the electronics. In this case, I don't want to tap into the battery itself to get power to the servos. So what I ended up deciding to do was use two 18650 batteries. These are normal lithium ion cells that you can get everywhere. And I just 3D printed this low mount that you can push batteries straight into, like that. And use two of them in series, and that powers the BEC board, which is a step-down voltage regulator. This one is made for the tricopters I used to sell, so it can deliver a lot of current. So this is just going to fit inside of the box. Electronics goes in, you turn it on, click, click. All right, everything so far fits together really nicely. And the last thing we need to do is figure out the drive mechanism. So obviously we're going to use sandpaper as the drive mechanism, but I also wanted to give it give something a try, and that's TPU. This is normal PLA. That's the stiff stuff that you normally print in. And if you bend this, like, it breaks very easily, like it snaps. But this, like, it's stretchy. It's really cool. It's super strong, and I want to see if it's strong enough to make it tread out of. So this is how it turned out. I have to say, it looks really good, feels really good. It's super flexible. You can bend on it hard. I made this thread type thing, so it looks cooler and also perhaps has a little bit more grip. I mean, look at that. So this should be good to go, so let's give it a shot. Okay, I'm just gonna do a quick test run to see that everything works before I jump in the car and drive for 20 minutes somewhere. I think the belt is going in the opposite direction that I thought it was. How could I miss that? That's so stupid. Okay, so in order to make the belt sander drive in the correct direction, we need to take it apart and see how it works. So this is a very simple circuit. It's literally just the battery connected straight to the motor with a switch in between. So as soon as the switch is closed, the battery voltage is applied straight to the motor and the motor spins. And that's it. So all we have to do really is switch the positive and the negative, and the motor is going to spin in the opposite direction. And the easiest place to do that seems to be at the battery connection here. So I'm just going to desolder that, flip the cables, and then solder it back together, then screw it back into place, and then have a test drive. Okay, I'm going to give it a try indoors. I'll see if it works. Okay, so changing the polarity worked great. It drives around, but the drive wheel is now unscrewing itself. To fix it, I'm just going to use some glue and a center punch, and I'm going to deform the threads, and the thread locker is going to hold it in place, hopefully. It's the strongest Loctite that I have. Okay, so I'm quite torn, because on one hand, it drives amazing, it looks amazing, but in order to get it to this point, I had to compromise my goals and make it drive the opposite direction, which the belt sander part is a lot worse now, because when you sand, it flings the dirt forward instead of reverse into this dust collection system. You can still sand with it, but it's not as good as it was. I also can't just go out and buy a new one in case this breaks and continue driving my RC car part. It also makes it a lot more difficult for other people to recreate this. I'm not 100% sure what to do at this point. I'm just gonna give Chad a call. Hold on. Hey, Chad.
Hi, David. How are you?
I'm having troubles
What's the matter?
the episode.
Okay.
Like it's working awesome. Like it's driving great, but I had to compromise. The original goal was to have an add-on just slide on the belt grinder and then go. But I had to have it go in reverse. So I reversed the polarity on the battery.
You built the structure backwards?
Yes.
So if I hear you correctly, you're saying you built the thing backwards, so to fix it, you're reversing the polarity on the motor.
Yeah.
Well, but how can you do that? Because it's a brushless motor.
No, mine's brushed.
It looks like this, right?
Yeah. Oh.
Brushless.
Mine does not say brushless on it.
So is it the same except it's not brushless? Because this was the only one they had.
Yeah, and I can't get that in Europe because I would have gotten a brushless if it was available.
I think it's really important that we stick to, there's two things. There's your vision of making this a radio controlled vehicle. And then there's the parameters we set for the show. And I think we need to maintain integrity with that. Like, I think we need to, you know, stick with our own rules. Like, I know it's hard. I know time's an issue, but I think we got to do that. I think you're going to be happier once we're done. I know you. We've been down this road many times. Sometimes you just need that pep talk and it'll be good. So do you think you can do it?
Yes. Thanks for the pep talk.
Of course. Yeah, and if you need me, like if you need me to do anything, let me know.
Sure thing.
All right.
Okay, talk to you later.
Thanks, David.
Bye. Now that Chad gave me an excellent pep talk, I'm gonna make the no compromise version. So the plan is to make something that fits inside of this nightmare of angles. So I was thinking of having something that goes forward here and then up, and then you lock it in place like that, and it's really on there. There is absolutely no chance of me being able to measure these angles and get that right the first try. So what I'm gonna do is use a very low-tech version, which is cardboard and scissors. What you do is just cut the cardboard. You start somewhere, and then the point that's tallest, and you just start there and then work your way until you get a good fitting shape. If you cut away too much, it's fine. You'll just use a bit of tape and then put the piece back on and you're good to go, or another piece. This is the finished version. So this slides on nicely here. And then I made another template for the handle here. What I do next is I take this and I put it in a flatbed scanner, and I always put a ruler in there as well. So you put that in the scanner and then you take it into the 3D software. Now I get an image of this scanned, then I'll go to calibrate. Now I can just trace around this part. I can do a pretty rough shape for the first try. 3D printed that. So now I have a version here that fits on here. The problem was that I got this angle wrong. So I had to cut this with the scissor, and then I just taped it back together. And now I scanned that again and fixed it in the computer. So it took a couple of tries to get this right. And this fits inside here. It fits really nicely in the slot, and it also fits around these bumps. So it feels pretty good. So I'll drill 4 holes in the aluminum plate and then just bolt that down. I think that's going to be really strong, and it's very convenient. The reason why it has this funny looking lip is because I want to reuse the front bumper and the light bar, because I think that turned out really cool. Okay, I'm just going to put the plate on here and we'll go from there. I really like how this turned out though. Okay, I'm going to put the front piece on. I added this cable braid to this little connector hub thingy that I 3D printed, and I just glued that in place. So now I can tug on this and it doesn't hurt anything. So I can very easily disconnect this and have this be connected all the time. So I don't have to connect anything. All I have to do is just smack it on and then it's good to go. Oh, it's cold. Okay, I'm up for another try. I'm quite nervous actually for this new design. I really hope it performs well, but I mean, it looks cool. Okay, let's get to it. Woo! There we go. Okay, so it's spinning around like crazy. I think that's because we have such a huge mass in the back. Yeah, it needs some weight. I anticipated this problem, so I brought some weights to put in the front here to weigh it down. Oh wow, it's so heavy now. Woo! Whee! Oh, that's so much better. Okay, I'm at a new location. I want to try it on asphalt, so I've changed to the TPU belt. Woo! Wow! That is amazing! This would be even better if you used a smaller battery. A 2 amp hour battery would weigh half as much, and then you could move this weight up front and have like at least half of this, maybe a third. So I made the modifications that I talked about. I got a smaller battery. It's half the weight of the other battery, roughly. And I added a weight on the bottom instead. So this is half a kilo instead of the 1.5 kilo, which we had here. So this is a lot further forward and it's a lot lower down. It also has the weight on the removable part of this. So it's not on the belt sander itself. Hopefully that works a lot better. Woo! Whee! Oh, nice! It is a lot slippery, more slippery. It's a lot more slippery today because it's wet, but it feels better than the 1.5 kilos. So I feel like I optimized this as to the limits. Like this, I don't think we can make this any better than it is now. It would be awesome if Chad built one and we raced. Is that something you want to see? Then post a comment. It looks cool, it drives awesome, it sounds awesome, and it just, I mean, just look at it. From this angle, you can see the thread on it. Like, how cool is that? It is perfect, I have to say. So if you enjoyed watching this as much as I did building it, please subscribe. Also, thanks for watching. I'll see you next time.